We are given a curve with the equation y equals 9 and a bunch of things. This curve crosses the x-axis at the point A. Part A, we need to find the x-coordinate of A. On the x-axis, the y-coordinate is 0, so we let y to be 0. When y is 0, then we have 9 x to the negative 1/2 minus 4 x to the negative 3/2 equals 0. In order to solve this for x, we need to factor out the term with the greatest negative exponent. So we take out 9 and we take out x to the negative 3/2. When we factor this, you have x to the negative 3/2. You add negative 3/2 to negative 1/2, and that will give us x. So negative 1/2 plus 3/2, that is 2/2, which is 1 minus 4, and that is 0. This term can never be 0. But the negative exponent means that x is in the denominator and division by 0 is undefined. What we have now is x minus 4 equals 0, so that x is 4. That will give us the x-coordinate of point A. Part B, we need to find the equation of the tangent to the curve at A. To find the equation of the tangent, we need to find dy dx. So for part B here, in order to find dy dx, we just differentiate. 9 here is just a constant multiple. We just keep this and we differentiate this term by term. So upon differentiating, we have negative 1/2 x to the negative 3/2 minus 4. And for this case here, we have negative 3/2 x to the negative 5/2. That will give us 9. Just keep the 9, it's fine. And then we have negative 1/2 x to the negative 3/2. The 2 negative becomes a positive, and that would be a 6 x to the negative 5/2. That will give us dy dx. But we need to evaluate dy dx when x is 4 at the point A. So in order to do that, it's actually easier if we write this in terms of square root. So dy dx in terms of square root, we have 9 negative 1/2. This is a negative exponent, so it is in the denominator. Then we have square root of x that is raised to the 3 plus 6. And then we have 1 over square root of x that is raised to the 5 here. We find the value of dy dx when x is 4. That will give us 9. Negative 1/2, 1 over square root 4 to the 3 plus 6 over square root 4 to the 5. So let's look at this. Square root 4 is 2, 2 to the 3 is 8, 8 times 2 is 16. We are negative 1/16. And for this case here, square root 4 is 2, 2 to the 5 is 32. So that will give us 9, negative 1/16. But both of these, 6 and 32, are divisible by 2. That simplifies to 3/16. And we have a value of 9/8. Then the equation of the tangent we have y minus y naught. So when x is 4, we know that the y coordinates is 0. Point A here has coordinates 4 and 0. The equation of the tangent, we have y minus y naught equals dy dx x minus x naught. So that will give us y equals 9 over 8x minus 4 and 8, 9 over 2. That will give us the equation of the tangent. Part C, we need to find the x coordinate of the maximum point of the curve. Maximum occurs when dy dx is 0. So when dy dx is 0, we set this, we just use this part here. So we have 9, negative 1 over 2, x to the negative 3 over 2, plus 6, x to the negative 5 over 2. This is set to 0. And in order to solve for x, we need to factor out the x with the greatest negative exponent. So that will give us 9x to the negative 5 over 2. We have negative 1 over 2. This is a negative exponent. When you factor out a negative 5 over 2, you add 5 over 2 to negative 3 over 2, and that is just x to the 1. And then plus 6, this is 0. This part can never be 0 because of the negative exponent. X is in the denominator. And we have negative 1 over 2x plus 6 equals 0. And solving for x, we get x equals 12. So the maximum point on the curve has an x coordinate of 12. Part D, we need to find the area of the region bounded by the curve, the x-axis, and the line x equals 9. So the line x equals 9 is somewhere here. But that is a maximum point x equals 12. So 9 must be somewhere here. We are finding this area. In order to find the area here, we integrate the equation of the curve from 4 through 9. Now, this equation has a coefficient of 9. We can just pull it out. Means nobody got time to put all that in. Then we integrate x to the negative half minus 4x to the negative 3 over 2 with respect to x. Let's integrate this. So negative half plus 1 is 1/2. That will give us 2x to the 1/2 minus 4. And that is negative 3 over 2 plus 1 is negative 1 over 2. That will give us negative 2. And then we have x to the negative 1 over 2 from 4 to 9. Okay, all the 1/2 here, just convert them to root because you have 4 and 9. It's easier that way. Here, 2 root x, the 2 negative becomes a positive 8. And then that is 1 over root x. So we can write this as 8 over root x that we evaluate from 4 to 9. Now we replace x with 9, so we have 2 root 9 plus 4 over root 9 minus all these when x is 4. So 2 root 4 minus 8 over root 4. And when we evaluate this, we will get 6 finally as the area.